Good afternoon. I'm back at it today. It's actually day 16 of Advent of Code, but I continue to be a day behind. So I'm currently working on day 15. That being said, uh, I stalled last year. Last year was my first year doing Advent of Code. Last year I got stuck on day 15, part one, and then I just kind of stalled, and so that's as far as I made it. So if we can get past day 15, this will be the furthest I've ever made it in Advent of Code, which was the original goal for this year. Um, so let's go ahead and see what we've got in store for us today. Got my project all set up and ready to go. I'm doing Advent of Code this year again in C#. I didn't feel like I was going to try to do it in Rust, but I got kind of started late on trying to learn Rust in the year, so I figured I probably wouldn't have much success. um, so maybe next year. Anyways, let's see. Day 15 is called Warehouse Woes. You appear back inside. Let me make myself a little smaller too. Sometimes I forget to do that after I make my thumbnail for a video. Okay. You appear back inside your own mini submarine. Each historian derives their mini submarine in a different direction. Maybe the chief has his own submarine down here somewhere as well. You look up to see a vast school of lanternfish swimming past you. On closer inspection, they seem quite anxious, so you drive your mini submarine over to see if you can help. Because lanternfish populations grow rapidly, they need a lot of food, and that food needs to be stored somewhere. That's why these lanternfish have built elaborate warehouse complexes operated by robots. Nice, these lanternfish are very sophisticated. These lanternfish seem so anxious because they have lost control of the robot that operates one of their most important warehouses. It is currently running amok, pushing around boxes in the warehouse with no regard for lanternfish logistics or lanternfish inventory management strategies. Right now, none of the lanternfish are brave enough to swim up to an unpredictable robot so they could shut it off. However, if you could anticipate the robot's movement, maybe they could find a safe option. The lanternfish already have a map of the warehouse and a list of movements the robots will attempt to make. The problem is, I lost my place. The problem is that the movements will sometimes fail as boxes are shifted around, making the actual movements of the robot difficult to predict. For example, whoa, that is quite the puzzle input, isn't it? That's an input right there. As the robot, which is the @ sign, attempts to move, if there are any boxes 0 in the way, the robot will also attempt to push these boxes. However, if this action would cause the robot or a box to move into a wall, a pound sign, nothing moves instead, including the robot. The initial positions of these are shown on the map at the top of the document the lanternfish gave you. The rest of the document describes the moves that the robot will attempt to make in order. The moves form a single giant sequence. They are broken into multiple lines just to make copying and pasting easier. New lines within the move sequence should be ignored. So that's important because when you parse this thing, you're essentially going to split it here, split it into two different parts. You're going to want to treat this like a grid, but you're going to want to treat this like a straight line. The rest of the document describes the move: caret for up, down for, or V for down. Was that greater than? No, less than for left and greater than for right. Describes the moves that the robot will attempt to make in order. The moves form a single giant. Oh, we already read that. Here's a smaller example to get started. Were the robot to attempt the given sequence of moves, it would push around the boxes as follows. So the first move is to the left, but it can't move left, so nothing changes. For next move is up, so it moves up. There's nothing in its way, so it can move there. Move up again. There's a wall there, so nothing changes. It moves right, which is a box, so it actually pushes the box over because there's no wall there, and then it moves itself to where the box was. Move right again pushes the box, or it pushes. Hold on. Yeah, move right again pushes on the box, which then pushes on another box, and because there's nothing here, both boxes can move, and this can slide over. So this scenario right here, to deal with the boxes potentially moving, we're probably gonna, that to me smells like something you could do recursively, right? Where you could say, given this position, can the box move? And then you can check the next box. You're going to have to check the next position, right? So you're going to say, can I move this box? And when you look over here, you can essentially say, oh, it's a box? Okay, check if I can move that box. And then once you get to an opening, now you just move everything over. Move right does nothing because now the boxes are going into a pound sign. Move right again does nothing. Move down slides all 4 boxes down. Move down again does nothing. Move right moves the robot. Move down moves him down. Move right pushes the box over. Move right pushes the box over again. Move down goes down. Move left pushes the box over 1 space. Can't go any further because of a box. The larger example has many more moves. After the robot has finished those moves, the warehouse should look like this. So this is our example result. The lanternfish use their own custom goods positioning system to track the location of the boxes, the lanternfish uses their own custom goods positioning system to track the locations of the boxes. The GPS coordinate of a box is equal to 100 times its distance from the top edge of the map plus its distance from the left edge of the map. This process does not stop at wall tiles. Measure all the way to the edge of the map. Okay. So the box below, shown below, has a distance of 1 from the top of the edge of the map and 4 from the left edge of the map, resulting in a GPS coordinate of 100 times 1 plus 4. Okay. The lanternfish would like to know the sum of all boxes. The sum of all boxes GPS coordinates. After the robot finishes moving in the larger example, the sum of all box GPS coordinates is 10,092. In the larger example, the sum is 2,028. Predict the motion of the robot and boxes in the warehouse. After the robot is finished moving, what is the sum of all boxes and GPS coordinates? Of all boxes is GPS coordinates. Okay, so I don't think this is terrible, right? I mean, they're definitely one of the more complex inputs we've seen this year, but not dissimilar to stuff we've done in other days. So I guess what I want is I'm definitely going to need a grid. That's our map of the warehouse and a list of movements. So I'm thinking I might want to do this a little different. Here's what I'm thinking. I'm thinking I can build up a dictionary. And that dictionary is going to represent our grid. And that grid will have a position. And then it's going to have, what's a good word for it? I don't want to use value. I want to use something like object or entity. I guess I could just have an entity. And that's so C sharp. It's too C sharp, but has an entity. Right? Yeah. And then I'm thinking we could have yeah. I think that this solution that I'm thinking of will take me longer to build, but I think it would probably look nicer. Do I want to do this? Well, I definitely know I'm going to need directions, which I have writ previously. I've actually used them several times now. Where is it? So I needed my direction class. I get distracted by the blue squiggles. So we definitely can use this direction class. I'm trying to think of what I should call the overarching thing here, though, right? What is this? This is a map. They're two different things. This is a map, and this is a list of movements. Maybe we do. Maybe we do something like public static from here. Just say public const, or actually this can be private. Private const string or character equals up character, which is going to be equal to this guy. Copy this. This will be down character. Actually, let's just go clockwise. Right character. And we can say down, left, and this is right. could say return char switch, and then I can never remember the base case. We could say throw new event exception character. And I think we could say it's an up character, and we're just going to return up. I must not have that switch expression C#. I can never remember the format. This actually should be up character, right character, down character, left character, row, say character, not expected direction value character. And then this is going to be up, down, no, right, right, down, and left. Okay, but it doesn't like that. Why doesn't it like that? Cannot convert expression type character to return type direction. Why doesn't this work? What am I doing wrong? I feel like this should work. Well, I definitely could do an if statement. So if character is up character, return up. So if character is right character, return right. If character is down, return if character is left character, return left. Otherwise, throw new argument exception, and we'll say character is not. Say name of character. And then what's it say? Yeah, that's what I wanted to do. I want it to be a switch expression. So what was I doing? I was doing something wrong. I don't know what it was, but okay. So now we can easily parse. We can easily parse a direction from our input, right? So if we read all lines, we can get var input parts. We can say equals input dot split. Actually, we're going to read all the text. Read all text. We can say dot split, and we want to split on two new lines, and we want it to be environment aware. So we'll say environment dot new line, and then environment dot new line, like that. And so our bar map part is going to be input parts 0 and var direction part equals input part 1. And so I'm going to turn this into map lines, and I want to dot split on environment dot new line. So this will be an array of type string, which is good because that's what I want that to represent my grid. Or my map, I should say. Then this is going to be my direction string, but I need to dot. Is there a way to filter? I want to. Or character. New line. String. Oh. Character dots to string does not equal. Basically, I want to remove the new lines. Yeah. Remove the new lines. And then the other thing I can do is actually I can just turn this into my directions. Because then I can say dot select. And then we can say direction dot from. And then to list, like that. Now we have our directions, we have our map lines. And we should probably add a test for that method, but before we do that, I'm trying to think about how I want to do the map. So I'm definitely going to have a class. Warehouse map. And it's going to have... I mean, it could just have the lines to begin with. Why do I want to use a dictionary? I guess the thing I'm thinking about a dictionary is it might be easier, might be faster to move through the grid, I guess is what I'm thinking. I don't know if that's actually accurate, but I'm thinking I could do public, private, read only, dictionary. And that obviously is going to have a position. And then it's going to have I mean, for now, it can just be a value, can it? It can just be character. We can just call character. That. We can call this positions. And here we can have a record, which is a position, and a position has an X, and X, and it has an Y. That, and it would help if I spelled position right the first time. And this is not a method. I can make a private constructor. And that's going to take this thing. So this also should be underscore. So we equal to positions equals positions. And then we'll have a public static member or method that returns the warehouse map. From, we'll give it a string array. And here's where we'll do all our parsing logic. Because I'm thinking what I could eventually end up with is I have my directions, then I have say var map equals warehouse map dot from my map lines, and then I'm thinking we can have some method on the map that takes in the directions, and then yeah, I think that makes sense. We got our position, we got our direction. What else do we got? We need to parse this. So what are we going? How are we going to parse this? Well, we're going to walk it, and we're going to say we're going to have a for loop, and we're going to call the this outer for loop is going to be y, and the thing we're going to loop over is going to be input dot length. Then the inner loop is going to be our x, and that's going to loop over input dot 0. That. Excuse me. And then we'll say that our positions equals our dictionary. We'll just say positions dot add new, and that's going to take our x and our y, and then our value is going to be input at y x, like that. and we'll return our positions. Oh no, we'll return a new warehouse with positions. Yeah, so that's the parsing part of it. And we should test that really quick, shouldn't we? Well, maybe we'll wait. I'm making pretty good progress, and actually nothing I'm... Maybe the direction I should test, just to validate, but anywho. So what's the question we're answering again? Yeah, so it takes the list of directions, and then we need to move the robot. So how about we have a method here called public, and excuse me, and we're gonna have a, it's gonna return a new warehouse map, and we're gonna say move robot, and that's just gonna take a list of directions. Bar positions, positions dot to dictionary, and that's because I don't want to mutate the original warehouse's positions. I mean, I could, but I just find it better when you don't mutate stuff. It makes troubleshooting and debugging stuff easier. So I think it's a good habit to just avoid it unless you need to. Like maybe if the allocation of memory is super expensive, maybe you don't do that. But this seems reasonable to do. So what do we do now? So we need to know where the robot is. Now, where the robot is, or at least we need to know where the robot starts. Now, where the robot starts is always going to be a function of this piece of state of our map. So we can actually do something like private read only position, and we can say, oh, we don't need read only, do we? Private position, and then we can say robot position. Robot position. Why can't I spell this? Robot position, and that's just going to be positions dot get try get value, and the value we're looking for. No, I want to do this the other way. I want to look up the key based on the value. Right? Yeah. So is this alternate lookup? Is that what that does? Gets an instance of a type that can be used to perform operations using a instead of a T. Okay, maybe that's not what I want. So gonna do some research. C# get key by value. Oh, okay. That's easy enough. I thought it would be more clever than that, but so we just say positions dot first kvp where kvp dot value is an @ sign. no, dot key. And then I'm actually going to say private const string robot or character, more like it. If value is a robot. And actually, we could actually probably make things clear by saying private const character wall equals this, and then private const character box equals this. Those will probably come in handy later. A little bit more expressive than just typing the actual character. Yeah. Are these are, I think those are O's, but I'm going to copy and paste just to be certain. Yeah. Okay. So what can we do now? We have a robot position, we have our wall, dictionary, robot. Okay. So what we can do is we can say our robot position equals position dot, no, it's just robot position like that. Then we need to, basically we need to iterate over our directions and perform the logic, right? So we need like for each bar direction in directions, and then we're gonna do the things. So I need to extend this position to get the next one based on a direction, which I've already written this. I've already written this logic before. Maybe at the end of this, all this advent of code, I'll try to extract some of the stuff that was very common across all of these into some sort of shared class library, some sort of utility. I've seen a lot of people who do advent of code, they have sort of like a utils library that they go to. So what are we trying to do here? We're just trying to get the next position. So position, and then we'll say position dot get next position based on a direction. Direction, and we'll say return new position, which is going to be the current x plus the direction dot xd and the current y plus the direction d. That. So for each direction, we'll get the next robot position, which equals robot position dot get next position. That takes in the current direction. And then this is where we need to have some logic to do this conditional. Right, so where does it say this? So as the robot attempts to move, if there are any boxes 0 in the way, the robot will also attempt to push those boxes. So we need to look for boxes. We need to make sure that wherever the box that's going to be pushed or they're going to be moved is a wall. Nothing. So the first check is actually super simple. So if we say if next robot position, we can actually use our positions dictionary. So we can say var next robot position, var next. Actually, let's not call it robot position. Let's just say next position. and then we'll say next position value is going to equal our positions dictionary, and our key is our next position, like that. And then if next position value is a wall, then nothing changes. We just continue on our merry way. The box, excuse me. Then the next thing we can do is we can say we actually are going to represent empty spaces with dots, aren't we? So let me look at my input, make sure that's the same on my input. Yeah, so periods indicate empty space. So then I can say up here, private const character empty, that it would be actually, so since I'm representing these each with a character, it would be actually be kind of interesting to turn these into records. And then, but I don't really know what to call all these. Like, what's a good common name for robot, wall, box, and empty? Right? I don't know. We'll leave it there for now. Let's see. Next position is wall. Then we continue. If next position value is empty, then we can update our positions, right? So we can then say positions robot position is going to be equal to empty, and then we can say positions next position now is going to be a robot. And then we continue. However, the more complicated one is if next position is a box, if next position value is a box, then we have some additional. So the first thing we need to do, we need to know, can we actually push it? And the way, the way we know if we can push it is if the space next to it is empty, which is easy enough to calculate. But we need to also take into account this situation, right? Where if we try to push the box, and the next box is a box 2, then we need to check the next box. So we need to kind of just recursively move in that direction, or continually move in that direction, and make sure there's at least one empty space after all the boxes, so that I can actually push everything. Yeah. So I'm thinking we'll have some sort of private bool, and we'll have something like can push box. And the can push box, what time is it? It's 1:30. And the can push box method is going to take the current position, or I guess the position of the box, and the direction it's being pushed, and make sure that, hey, this is all good, hunky-dory. So Yeah, so let's say this takes position, which is the box position, and then direction, which is the just direction that's being pushed. So if it is a box, we need to say if can push box, and we'll give it the next position and then the current direction. And what do we do with that down here? So the first thing we need to do is we need to again get the next position, but this is based on the box's position now, right? And so we need to get the neck bar next position value. Oh, and we also need to pass in, since we're not mutating this map's positions, and we have a local copy of it, we need to pass that through to our box function. So we'll say can push box, next position, direction, and then the current state of the positions, because as we're looping over the directions, right? Sometimes we may or may not hit this point, but it's likely at some point we'll have mutated this positions already. So we need to be referring to that local copy and not the field on the class, on the instance. So this needs to be a dictionary of character, like that. And somebody's probably saying, well, why aren't you mutating the instance level positions? And I'm not doing that because I think it'd be kind of nice if you have an instance of a map, you can give it different lists of directions, right, over the course of its lifetime, and get back a new version of the map with the directions applied, but still have the original state of the map preserved, right? So you could theoretically have one instance and get multiple different copies or multiple different versions of that map given a particular set of directions, which I don't think that's really a requirement of the solution here, but I'm just trying to practice I'm just trying to think thoughtfully about the solutions in a way that applies to maybe how you would think about actually building solutions to real world problems. So yeah, so I'm just going to go down here. Like that. This is going to become positions, next position, like that. Now we actually need to do our check. So the first thing is if we've encountered well, what does it C sharp dictionary does index throw if key not found? I actually don't know. So it will throw. So I probably don't want to be doing this. What I probably want to be doing is position dot try get value next position out bar next position. This probably needs to be if as next. And I want to say if as next position is false, then return or no, then continue. So this would be almost like a way of saying, hey, we've gone off the grid, right? If that position doesn't exist in my dictionary, it's not valid for the grid. Then I can safely access the value knowing I've already accounted for that here. So that's what I want to do here too. Next position. It's probably a way to dry that up. We probably have a private method called get next position and then wrap all that in there, but this is fine for now. So if has next position is false, then we can just return false. If the next position value is a wall, then we can return false. If next position value is empty, we can return true. Let's see. If what do I say now? If, sorry, I got a message and it threw me off. Let's see. Yes, once you stop mutating objects, everything becomes easier. That's so true, Silly B. So true. Yeah. I mean, I'm guessing there's kind of a memory thing where you have a lot of extra probably allocations, but seems like memory is relatively cheap these days. And if it saves you the heartache, right, of trying to keep track of where a particular thing mutated another particular thing, probably beneficial in the long run. Yeah. So if the next position's a wall, we return false. If it's empty, we return true. This is where, though, if the next position value is another box, this is where we want to do a little bit of recursion, I think, and just continue to walk that line to make sure we find not expensive with all small data. Yeah, I totally agree with that. It's like yeah. And I know, like, fundamentally that's kind of a paradigm thing, right? In certain languages, like I've been trying to learn a little bit of Rust, and that's kind of very, as you're reading that the Rust language book, it's very forward about the fact that, like, by default everything's immutable, and you have to explicitly opt in to mutability, which seems like the better path forward. Like, make the dangerous thing, or not necessarily the dangerous thing, but make the potentially error prone thing, make it very explicit that you're like inviting that, I guess. Okay, so next position value. This is where we're going to do something that looks weird, right? This is where we're going to do our recursive call, I think. We'll just have a base return false here. But if we can't get to if the next position is a box, then we're just going to call this same method again. Return can push box, but now we're going to pass in the next position that we calculated here, and the direction. What doesn't? Oh, and the positions. And the positions. What? convert recursion to iteration. Oh, it doesn't like the recursive solution. I guess Rider doesn't like the recursiveness. Okay, that's fine. I understand recursion can be a dangerous game, can be a foot gun, so we can do this. That's fine. So basically, we evaluate the all the, but let's actually just do this early, right? If we have to keep walking the thing, let's just walk the thing early. Into a switch statement. Okay, let's try that. Now we can duplicate these cases, I guess. Yeah. And then we can actually just remove that case. So if it's empty, we can move it. If it's not empty, we can't move it. If it's a box, then we walk till we find an empty solution or an empty position. And then this can be static now. Okay, if we can push the box, then we need to actually push the box. So that's also going to be a similar type of method, only instead of doing this like check for conditionality, we're actually going to mess with this dictionary. Which is which we're not mutating the dictionary here. So I think what I might do in the name of in the name of what we just talked about immutability and mutability, maybe what I do is I then return a dictionary out of this method. We say position, say push box. It's going to basically have the same signature. I guess I could combine these. I could combine these, couldn't I? But I'm going to keep them separate for now, for clarity. And then we'll make a local copy here. Oh. Maybe we say current, like current. I mean, I could do this all inline too. You know, since I'm already I am mutating the dictionary here locally. So I could do this all inline, I guess. Like here. Should we do that? Do we move it in line? Yeah, let's just move it in line. So if we can push the box, then what are we going to do? So if we can't push the box, we are going to. Oh no, I don't want to move it inline because I'm going to have to do something funky like the recursive call or the iterative call here. So we're going to say, let's see, push the box. We have the boxes thing. And so then we're basically going to do the same thing. But we want to use, positions, next position, position. Yeah, okay, has next position. And then we're going to say if has next position is false, you just need to return the positions. Otherwise, if next position value is box, this is where we would call push box again, passing in our next position, our direction, and our positions. Which I'm guess Ryder's going to want to change that once we get down here. But otherwise, we're going to say return positions, and we are going to do our actual manipulation. So we're going to say positions box position becomes, what does box position become? Box position becomes empty. I think it becomes empty. But I'm thinking about, do we care about what was there to begin with? Yeah, I think we do. I think we do. Well, actually, no, I don't, because I just want to make sure I'm pushing the box into an empty position. So I actually, this is always going to be, empty. And then positions, next position is going to be the box now. Then Ryder doesn't like the recursive thing. It wants us to do an iteration. Fine. So if it doesn't have a position, we'll return out. If it next position is a box, then we'll update our positions and keep iterating. And then finally, if we get to a place that's not a box, and we don't need to worry about the wall and all that because I've taken care of that in my can push box method. So just kind of separated concerns. I could put them together, but I don't know. Maybe it makes sense to have them together. I don't know. Let's see, positions. The only thing I need to make sure we do here is we need to make sure and reset the positions. So when we say can push box, and we give it our next position, our direction, and our current positions, we just want to make sure that we, not can push box, push box. Because that method is going to do some stuff, right? It's going to change some positions. So we need to change those. And then we need to move our robot. Now we need to move. So our robot's pushing. So at this point, like it pushed. We moved all the boxes. Now we need to move ourselves. So we say, what do we say? We say positions, robot position. I guess we just say this, right? We just do this again. Because our robot's here. We push the boxes. Let me go back to my input. Like, so we're thinking of this case right here. So like robot said, I say push box. Those boxes are going to now all slide to the end. So now this is going to be 0, 0, and there'll be an empty one here. And so now I just move the robot there, move the empty where the robot was. Okay, cool. Running short on time here. I need to probably get to a stopping point in the next 5 minutes or so and pack it up for lunch. Okay, so did we... So if it doesn't have a position, we continue, nothing changes. If the next position is a wall, nothing changes. If next position is empty, we can just swap the positions. If next position value is a box, then we go through this. Is there any other check we need to do after a box? I think that's it, isn't it? Robot wall, empty box. Yeah, I think that's it. And then at the very end, we return the new warehouse map. So this would actually could actually be var move robots directions. And then we need a method to actually calculate the value we actually care about, which is the sum of all boxes GPS coordinates. So get maybe we call it total box coordinates or something like that. Say public calc, or it turns an int. I think it'll be an int. We might need a long. Public int calculate total box GPS coordinates. I could also return all the GPS coordinates and then sum them, I guess. But I think this is fine. So what this is basically is just this is just x and y, right? So this is y. This is x. So it's always 100 times y plus x, right? 0, 1, 0, 1, 2, 3, 4. So we can say var box positions equals positions dot where kvp dot value is box, and then select kvp kvp dot key, which is the position. Then at this point, we can just iterate over them. So take var total. I'm guessing Ryder's going to want to convert this into a link statement, but for me personally, it's always easier to think initially in terms of a loop. Personally, so we say box positions, and then we say var position will just be var GPS a GPS coordinate of 104. So yeah, var GPS coordinate. Oh, I guess I could put this logic on the position, couldn't I? I could say public int calculate GPS. Then it actually, I think, gets really simple, because then I can just say I mean, this could even be a property, couldn't it? It could even be an expression body that's like doesn't even necessarily need to be a method. It could be public int GPS coordinate. That's just equal to 100 times y plus x, like that. And then up here in my loop, well, this becomes a very simple link method at this point, because then you can just say dot sum e dot GPS coordinate, like that, and then just return it. I've written no tests, and this all has felt so, it all has made so much sense in my mind that I know this isn't going to be right on the first go. That seems to be how it always goes. So then up here, we can just say move robots, then calculate total GPS coordinates. And then that actually becomes our result. And we can actually just put these on a new line. We can say the sum of all coordinates. The sum of all boxes GPS coordinates is our result. Okay, I think I'm just gonna give this a shot against our input and see if it's right. If it's not right, then I'm gonna pause and I'll come back later today and I'll add some tests and I'll figure out why it's wrong. But I've all but run out of time on lunch to work on this, so let's give it a shot. So I have my input already, so this is going to be .NET Run project day 15. And this is called, what is day 15 called? Warehouse Woes, right? Warehouse Woes. And give it my day 15 input. Oh no. Character is not a valid direction. And then, well, okay, I said I wasn't going to try to troubleshoot this, but okay, I just, one sec. I just want to see. It's not even getting past the parsing, which is disappointing. Name of character is not a valid direction, and then we'll actually put the character. See what the problem is. Oh, it's just an empty space, I guess. Oh, maybe I need to input parts. Our string is not. It's not environment new line. It's not equal environment new line and character dot to string. It's not equal string dot empty. Oh. What is the character it's tripping up on? Well, maybe I could go about this a little differently. Maybe what I do is I split this on environment dot new line, and then I join it on string dot empty. I want to just filter out the characters I don't want. In any event, I need to give it some. Let's say function characters. Oh, whoops. This should be string dot join. Doesn't it like about that? I just want to see what the heck is in this, in these characters. Is it because there's still a new line in there? I don't know. I'll come back to this. I'll write some tests and we'll get to the bottom of this. But I've got to pause for the day. And I'll be back later to actually solve this. I really need to solve day 15, and I need to really solve day 16 today and get back to being on track. In any event, thanks for watching. Thanks for hanging out with me on lunch and working on Advent of Code. Otherwise, I'll see you later today to actually solve part 1 and to actually solve part 2. So there will be a lot of puzzle solving today, as I try to get through 15 and 16. If I get through 15, that'll be the furthest I've made in Advent of Code, and I'll be super happy. So I will see you guys later. Hope you have a good rest of your afternoon. See you then. I'm back, and we're gonna try to tackle day 15 part 1 some more. So where we left off was... Where we left off? Okay, where we left off was basically we tried to run this against our real input and it threw an error. So there's a character that's in here, some sort of control character. There's some like new line or something that I'm not filtering out here in this logic. So what we're going to do is we're going to do what we should have done from the beginning, and we're going to add a class. I'm actually going to call this puzzle parser test dot, and I'm actually going to make a new class that does this parsing. Parser public. Actually, it can be a static. It can be a static. So public static. What should it return? It's going to return directions, right? Maybe we could say it returns a list of directions and a map. So a tuple that's going to be a warehouse map, we'll call that map, and it's going to have a list of direction, and we're going to call that directions, but lowercase, not lowercase, capital case. We're just going to call it parse, and it's going to take a string. And in here, we're just going to move all the logic from here into here. And also this. So we'll say this will be moved into here. And, what are we going to return? We're going to return thing of new, and it's going to be a map that's going to take a positions variable and then directions like that. Yep. Map lines. Map lines just needs this guy. Map equals this. Okay, the point of doing this is to just make it a little bit easier to figure out what's going on in here. So what we can do then up here in our program CS is we can remove all this stuff. But we can remove most of this stuff, and we can just say var map directions equals puzzle parser dot parse the input. So like that. And then this just becomes map. We can probably put this all in one line now. We don't have anything to do with. No, do I want it to be abstract or do I want to make it static? I'll make it static. Okay. So then over here, what we can do is we can say test public async task. My microphone's working, right? Yeah, my microphone's working. Okay, public async task parse when called it should return expected, or it should return map and directions. And I'm honestly not going to get too much into the weeds here. Private async task of string. This is going to say be called get puzzle input. We've written this 100 times now for admin code. We're going to say return await file dot read all text async. Path is going to be app context base directory. We're going to read the file that's called input. Then here we're going to say var input equals await file dot what do you want to call it? Oh, no, not file. It's await get puzzle input. We'll say var result equals puzzle parser dot parse this input. Then we'll say await assert dot that result dot map is of type warehouse map, and await assert dot that result dot directions is type of list direction. I know that's kind of a stupid simple test, but this will let me set a breakpoint right where this exception's getting thrown. Right here. So now we'll build. Now I can run this test. Uh-oh, there's an error. What's the error? Could not copy. What's the error? Why couldn't I find the what? Should be an input. Why isn't it getting copied? Right there. Let's try again. What the heck? That's weird. Remove that. Oh, this shouldn't be here. This should be Rs1. Whoa. This was building just fine earlier. Like literally a minute ago. building distance. Could not copy. Oh, well, that's a whole different project. And I don't have that created yet, so put .txt, that's gonna go there. We also need to add a problem. Okay, gotcha. Okay, now we should actually be able to hit that breakpoint. So this is where the error is going to be thrown. So now we can say debug. Yes. And we should be able to see what character is causing this thing to. Oh, okay. So when we're parsing, we basically need to account for all the different versions of new line. So doing this is not good enough. So what we should do is we should say var stir equals character to string, then return stir is not that, or this is not that, or this is not carriage return new line. We should try to run this again. I guess I can't do I can't do pattern masking there, so I just need to say does not equal, and does not equal. Oh, I guess I shouldn't have been saying or either. Stir does not equal. Now this should pass. There we go. Okay, so now I'm just curious how close we were on the first try. So if I run this again, we should actually get a number. Line 16. Oh, that should be not be arg1, that should be arg2, or arg0, sorry. Okay, let's see if this is anywhere close. If it's not, we'll have to start writing a bunch of tests. Oh God, what did I do? That's not the right answer. Your answer is too high. If you're stuck, make sure you're using the update input. Okay, so, well, we're wrong. So let's go back and let's write some tests. So this is our example input. Not going to look pretty in any of our tests, but we need to check to see if we have this right for our example. Okay. How do I want to do this? Let's go to our, let's create it. Okay, let's create a class called warehouse. Private read only string array, which is going to be the example map. The cursor. Oh god. That, and then we'll also have private read only string, and this will be example example directions. This honestly actually make this an array too, even though that's not really how we're dealing with it anywhere else. We will just deal with it that way here for our test. Otherwise, one big long string is going to look pretty ugly. Yeah, we're going to say direction example directions input, and then I'm going to have another one that's actually called private. No, that's fine. That's fine. Let's leave it like this. Stop putting that on the new line. Then we'll have a test method, public async task. I think we want to test, to begin with, we want to test get calculated box GPS coordinates. All the example input. Which is, okay, so then we're going to have our map. Our map equals warehouse map dot from our example map. Our directions equals string dot join. I'm just going to join them empty. Example directions, and we'll say select from to test. And we'll say bar result equals map dot move directions dot calculate that await assert that result is equal to, what was the number? It was like 104, wasn't it? No, 10,092. In a smaller example, it's, so which one's the larger? Is this the large example up here? And this is the small one down here. Okay, so when given large example input, call this large build this. Let's run that test, see where we're at. Got that one wrong. 9,700. So yeah, so we're off. Okay, so let's do this again. Only now let's take a look at the smaller input. That should be much more manageable to look at. When called with small. Read only string all example map. Small example directions. Oh, this is also going to be a array. In this case, it's just one line. We could also parameterize this and say example input. We could call this has method data source name of is calculate total box GPS coordinates. Test cases. Then we could come down here and say public record, and we could call this a string array of map input and then a string array of directions. We could have another method that we could call public I enumerable of func. This then the first test can say yield return our new, and then we'll say large example map, large example directions, yield directions like that. And then our test method, getting kind of long in the names here. And then we can say test case map input and test case dot. Oh, and then we also need the expected value, don't we? We need int expected. In this case, it's going to be that. Yeah, and a smaller one, 2028. Build. So let's see how far off we are on the small one. Let's see. Tests, close tab. Oh, let's just run them both. We just run all of them. So 1624 versus 2028. Yeah. Let's call this map. Map after directions. Or map after robot equals map move robots. This way we can kind of compare the positions, right? And we can set a breakpoint here. Debug this. This mapped after robot moved. We should be able to look at its positions. And we can, let's see, I guess it's calculating a GPS coordinate for things that aren't a box, but that's fine. Honestly, I don't care. What's the small map look like? Where the robot to given, it would push around the boxes as follows. This is the final, so let's see. 2, 1. Yeah, that's not right. Because that is 0, 1, 2, 3. 0, 1, 2, 3. Oh no, I'm over here. Sorry. 0, 1, 2, 3, 4. Yeah, so something's off with my logic. So the best way then to do this, I think, the best way to do this is to actually check that between from this move to this move, they're right. So let's go back to Rider. What? Oh, this needs to be static. Let's give me that one. Let's see. I think. Oh, I can't mark this private because then it won't work in my yeah. So I can't do that. Can it be protected? No, it has to be public, which means it should be static. Which means these things up here need to become static. Private, we don't have static. Oh. Should be private, static. We don't. Huh? Oh, just stop. Private, static. Fix these names. Fine. And we should make these private, static. Static. Rename them. Rename them. Okay, so I think what I want to do is I want to go back over here to my warehouse map. Right now, this is just a field, and it's private, but I'm gonna make it public. And rename it to positions. It can still be a field, that's fine. But now in my tests, let's see, now test casing task move when called should move. It should move items. Should move values to expected positions. And then what's that going to look like? Well, we're going to have an initial state, and then we're going to have an after state. So I think let's make a new set of test case stuff. So we'll say public record move test case, and this is going to have a string like that. Oh, I know what I'm going to do. I'm going to add a method on here called add a method to this warehouse map that basically prints this to a public. Because this if I just parse this to a map, then I have my dictionary. So what do I want to do? I think I want initial or like map input, and then is going to be expected map like that. And this is going to be public enumerable a func test case to test cases and yield return new. This can just be two different arrays. So I can say, here's my initial state. escape. Let's go like this. Yeah, like that. And then up here, what I can do is I can say method data source name of move test cases. Then move test case, and then I can just say bar expected equals where warehouse map dot from, not warehouse, warehouse test case expected bar map equals or bar, we just say bar result equals dot from test case dot map input dot move your robots. Oh, and we need directions, don't we? So this would be just a string. This we can say string that. Say bar directions equals test case dot directions dot select direction dot from to list. We'll pass in our directions here. Oh, but we don't want to move all. We just want to move one. So this actually just needs to be direction and direction dot from test case dot direction. Because we actually only want to test moving, or at least in this case, we're only wanting to test moving once. So we're actually only wanting to test the first thing. We can still leave it as a string. We can still imply it's multiple. And we can still do test case dot directions dot from dot select direction from, and then dot and this can still be called directions, but in this case just one. We're just moving once. And then the whole point of all this was so that I could say await assert dot that result dot positions dot is equivalent to expected dot positions. I actually don't know if this tells me anything more than what I already knew, but hopefully this will allow me to kind of start to tease apart oh, interesting. Okay, so that one's right. Okay, that what that basically means is that case, I'm handling that case correctly. So we should be able then to do this one, which is basically all we have to do is just copy this case, paste it, give it a new different direction, right? Give it a different direction. this becomes our initial now. Or actually, it didn't change, so we don't have to do anything. Then now, after we move up, we get this. Probably easier if I just change the characters that actually change. I was getting ready to repaste that. Okay, so now we can build, and we should have another case. And let's see if those all pass. Yep, okay. I'm guessing it's the box case is the one where we screw up. So again, we're back here. We're going to copy this case again. Still moving up. So we basically just expect to have this twice. So we should start here. We try to move up. We're still here. So build. Okay. Move right. So this is the first time we actually move a box. So let's go over here. Right. Right. And now this should become a period. This should become a O, and this should be the new robot position. That worked. Okay, so let's try this one. So basically moving right again. Basically moving right. Or hold on, down here. This probably makes sense to have in a separate class because of how lengthy this test case is, but so these guys go here, or this whole line goes here. That, and then it should end up like this. Is this one we're messing up? Yeah. Okay, so this is messing up. So what are we actually getting? I should set a breakpoint before I do that. Oh, I already know I failed. I want to debug it. Okay. Excuse me. So here's our test case. Here's our expected input. So if we were to explore this, this is expected. And this is what we're actually getting. Oh, actually I could look at it in this context. Yeah, that's not as easy to visualize. So let's find a way. Stop this. Let's find a way to actually say program. And let's just say warehouse map, robot position, positions, and let's have a public read only map. Oh, it's all private. So let's add a public method here. Public to let's say var conditions dot select key avp dot key dot max key var max y, basically same thing. Of the position, and we'll say for each var we'll say for that y x. Why did it invert that loop? R x x max x. Actually, let's make this x. X. This is going to be max x. This is going to be y. We'll say our value say value equals positions, new position of xy, row dot append value, and map append line, row, what does that mean? And then it means in here, I'm going to have a property that I can look at that's just called private string array map, and I'm basically call toString, and then I'm going to split it on read only, so that when I do this, I debug it. My hope is that then I can say, oh, that's interesting. It changes what's printed here because I overrode the toString. So result.map is this. Interesting. Hold on. What am I looking at here? Test case. Why is my string, why does it look different? Expected map. Did I put these backwards? Did I mess up the parsing here? Yeah, input length is our Y, input X. That should be right. Let's flip these again the way I had them. Y. Oh yeah, it should be Y because I'm building up the row. So this should be Y. Y. Be X. 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 Yeah. Okay. So stop that. Redo it. This is why you should write tests first. But here's my expected map. Which, yeah, that's what I'm expecting. And then here's my map that I got. So not even put it down here. Why did it put it down here? It put this O in the right place, but that one's not. Okay, so it's somewhere in our push box thing we're screwing up because we're getting the robot in the right place and we're getting push box. Where's the push box method? Push box, there we go. Let's see, next position, box position. If next position is box, then we set box position equals next position. We set current positions. New positions. Hold on, why are we doing that? We don't need to do that. Yeah, so let's just let's set our breakpoint in here. Before we make any changes, let's just try to understand where we're going wrong. So box position is x equals 4, y equals 1. Next position value is a box. So then we're going to step in here. And we're going to get next position is the box position. Then current position, right? We're step over. We should continue. We'll come back up here. Position. I don't think this needs to be in the loop, does it? I don't think that needs to be in the loop. Yep. Now this should be -1, or this should be empty. So we should set the box position to empty, set this position to the box. Return positions. So what does our positions look like at this point? Oh, okay. So I think I don't think we're hold on, let me move this and debug. Shit, I took my thing off here. Takes me a minute to get my brain wrapped around this stuff. Yeah, I think I'm just not setting this position, and I should be. So where should I be setting that? Should I be setting it in here somewhere? Yeah, should I be setting it in? Well, first of all, let me stop that. This doesn't need to be in the loop. This doesn't need to do that. I think I'm doing that in here too. No, I'm not. So in here, when I return the new position, I'm setting the next position to robot and the robot position to empty. So beef. Yeah, I feel like I'm missing something in this method to handle the successive iterations. But I'm having a hard time thinking of what it is. Which I think is why I want to do this recursive. Um, so let's try going back to that solution before we make things recursive. So here, what I was going to do is if it was another box, I was going to say return push box, and I was going to give it the next position, the current direction, and our positions. Like that. Now, what happens in that solution? It still doesn't work. Oh, I think I need to be checking for an empty, don't I? Do I? No, I think what I need to be doing is let's go back to our loop. I think do I need to be doing that? Yeah, I think that makes sense. Debug. Wait, I think now we're missing. Why don't all these have an ending? Only this first line has all the asterisks. Why don't? Because I think this should be less than or equal to, shouldn't it? Well, no, I want to actually... I mean, I know it doesn't matter, but I know that I put that method there purely for... But I want to see the actual... Yeah, so there now. Got my thing. Okay, so now let's see if my math works now. So if I've got the movement right, let's see if either of these run now. Okay, so that's the big one. Does the small one work? I'm still off on the small one. Okay, so the only thing that I can do is just keep going through these moves test cases, because somewhere in here I've screwed up. So this was the next one. This isn't very thrilling to watch, but this is how it's done. Yep, and then it's going to move right again. Nothing happens. We should pass that one, no problem. This one goes down. It's going to be a down arrow. In which case now all these need to move down one. So that becomes O. This becomes at. And this becomes dollar. I mean a period. Ah. Okay, so all those are still working. But somewhere I go awry because this doesn't succeed. So this is another example of this is another example where it doesn't move, it just stays the same. We go from this to this, that's the same. Then we go left. In which case, this could become this. My direction is now this guy. Then we go down. This is why it takes me so long to solve any of these things, because I can't figure it out any other way. I'm just tired of moving my window around so much. This is the new one. Down. this. That's where we start. Then it becomes at, period. Then we go right. We should go from this, which is going to be period at 0. Go right again. Right again. Which makes it like this. Go down. Good. Then we go again. See if this goes left. So this should get shifted over. Let's see if they all succeed. Okay, why does this one fail? I wish there was a way to see the inputs and outputs better in this test view. Which way are we going? We're going right. Let's see. Wait, is that just a bad test case? Did I just copy and paste it wrong? Cause right. Yeah, this doesn't look right. Somehow I flipped it. Let's see. What did I do here? Oh, this should be down, shouldn't it? Well, maybe I didn't flip this anything. Okay, so maybe my move logic is fine. Is it just a problem with the way I'm calculating my... Okay, if KBB value is a box, key, sum, GPS coordinate, coordinate is 100 times x, or 100 times y plus x. Okay, so let's dig into that a little bit, because it seems like maybe I'm moving them right, but I'm not. Let's see. So we say var boxes equals positions not where list, and then we say return this dot select explore debug boxes. We have 6 of them. Oh, you know what? No. Let's see if all these boxes are in the right spot. So we got 3, 1. Do we have 3, 1? No, we do not have 3, 1. This map is all screwed up. It's got multiple robots. But what the hell is happening? Something weird is going on. Something weird indeed. Well, let's step through this. Debug. We should be able to step through this and see this map change. So here we are. Oops. Should be able to see this map state change and be able to see where things go awry. So the first time we move, nothing should change. The first time we do, nothing should change. Then we should have our robot move upward, but it didn't. No, that makes sense. It should this should not change, but these positions should change. And then we should get down here to this guy. Yeah, those positions actually shouldn't change. It should just be where's the test? Just be this guy. So let's continue. Remove that. Yeah, so what the freak is happening? I'm placing robots in multiple places and none of my stuff is getting pushed around. Well, now I feel like my approach to this problem has made it 6 times more difficult than what it is. Oh, my leg fell asleep. Oh god, my leg fell asleep. I'm doing this so I can just see how these maps are changing on each iteration. So we did move up, so that's good. Okay, so here you can see something got screwed up. What's screwed up? So it's basically like I'm moving it and then I'm starting over. So is this not? This is still saying it's at x2, y2. So is this still a reference to the I see what's happening. Okay, I have an idea how to make this better. We are going to have a temp map, and that temp map is going to be the map we work against. Map equals new map, or warehouse map. The robot position is then going to be a temp map dot robot position. This is going to be temp map. Oh no, we can't do that because can't we do that? I think this will solve the problem. I'm not sure I like the solution, but basically that robot position was always referring to an outdated position. Now what we're doing is we're basically having a temp map that we mutate on each iteration. Yeah, so that's not going to work when we need to reset the thing. So actually back this up. Back this up. This is fine. But what we actually need to be doing here is we need to get this inside the loop. And it needs to come from our positions dot first kvp, where kvp dot value is robot. Dot key. This can go away, and I think this fixes our problem. Yeah. Gosh, dang it. I tried to make it easy on myself to not mutate things, and then I screw up the looping. Okay, so this can go... Oh, this is redundant. I don't need to check this twice. That was kind of a nasty little bug I created for myself there. Let's run all our tests and just make sure we are all square now. Yep, okay. This writer wants to make these into a switch statement. Just fine. I don't know if that's any more expressive. Yeah. Okay, and then now we should be able to run this against our input and get the right answer, which I think it should be lower now because when we submitted our last answer, it said we were too high, I think. So let's try that. I got it. I keep doing that. Submit. Yay! Let's go. Oh, part 1. God, that was a nasty little bug I made for myself. So just to talk through that bug again, what I had done was I was basically, every time I was entering this loop here, I was referencing the robot position, but I was referencing the robot position outside of the loop, and it was basically static to the current map's robot position. And since I'm not mutating the instances levels of position, this robot position is out of date to this position. So that needs to come inside the loop, and I need to derive the robot out of the positions that I'm mutating as I loop over all the directions. Which also means that this really doesn't have any purpose. And that this property was just there for debugging purposes. I can leave this public because I am using that. I'm using that in my tests. But now I should be able to write a test for the puzzle input, shouldn't I? So should I put this in the parser? Probably not, but the logic to get the puzzle is already here, so I'm just going to say task part 1 solution when given puzzle input should expected. And I can kind of make it a full, almost what you call like an end-to-end test. So I can say var result, I can say var map directions equals puzzle parser dot parse the input. Then I can say why isn't it like that? Oh, I need to wait it. Then I can say our result equals app dot move the robot according to these directions, then calculate that, await, assert that result is equal to this guy. And then if we run our tests again, they should still all pass. Yeah. This is a little slower though with my fix. See, it's almost a second. Almost takes a second. Feels kind of slow. Wonder if there's a reason for that. Okay, should we try to do part 2 or should we take a break? How complicated is part 2? Just as they start. Everything except the robot's twice as wide. To get the wider warehouse map, start with the original map and for each tile make the following changes. If the tile is a star, the new map contains instead. If the tile is 0, the new map contains. This instead was zeros are boxes, right? This will produce a new warehouse map, which is twice as wide with wide boxes that are represented by these. The robot does not change size. The larger example from before would now look like this. Because boxes are now twice as wide, but the robot is still the same size and speed, boxes can be aligned such that they directly push two other boxes at once. For example, consider this situation. For example, or after appropriately resizing this map, the robot will push around these boxes as follows. Push. Push. Move down. Move down, move down. Oh, that's a sneaky little case right there. Right here, see? So now that the robot's here and it's pushing up on a partial box, it pushes all of these back. That's tricky. Yeah, I'm not going to start part 2 now. I'll do part 2 later. Okay, yeah. I'm going to hang up here, or I'm going to stop here at part 1 solution and then part 2. So this, if I solve this part 2, it will be the furthest I've gone in Advent of Code to date. So I'm going to stop here for the evening. I'll come back a little later tonight after I've taken a break. This is going to be a long video because the first video was about an hour, or the first part of this video was about an hour. This one's an hour and a half to 2 hours and a half. So yeah. Yeah. Anyways, thanks for watching. I'll be back on a little later, probably. See you then. All right, I'm back at it. So this is going to be day 15, part 2. I honestly have no idea how I'm going to make this happen. I think the solution I implemented for part 1 might actually make part 2 harder. One thing though I did want to see is I noticed that my solution to part 1 is kind of slow. It's like almost a second. 800 milliseconds. I wondered if I could maybe make that better by not doing this on each iteration, because this is probably kind of expensive. So I had an idea to put back the robot position, private position, robot position. So I had an idea to put this back so that it can be accessed on the instance when you want to. Like this. And then my thought was that I could move this obviously to the outside. So I would just do that lookup once there. And then down here, I guess down here I was thinking, could I just update the robot position? So robot position equals next position, like that, and just keep track of it locally right now as I iterate. Yeah, see, that's much faster. That's 8 times faster, right? If that 148 divided by 899 divided by 148. 6 times faster doing it that way. Because this actually requires me this call, right? This call right here requires me to actually go through every position in my dictionary and look for that value. And if I'm doing that on every iteration, right? If I have 10,000 directions and 10,000 positions, right? That's a lot of times I'm going over that same spot. So I think this will work. I think that all my tests should still pass. Yep. Okay, so it's faster now. Part 1's faster, but I need to tackle part 2. So the first thing with part 2 is we need to be able to expand the list or the map. We basically have to go from this. We have to go from this to the wider version, which is this guy. Let's see. So I think what I'm gonna do is what do I do? Okay, I think what I'm gonna do is I'm gonna have a new class, and I'm gonna call it class wide. Oh no, class wide warehouse. Excuse me. And I think what I'm gonna do here on the existing warehouse is I'm gonna have some sort of method. Why don't I just put it? I just put it here, and I'm gonna call it public. I'll turn a wide warehouse. I'm just gonna call it scale horizontally. That's not how you spell that. Rename to horizontally. And this logic is going to transform the existing positions into the new positions. And that the idea there is basically we just have to go over the rows. We just have to go over the rows and perform the transformation. And so how do I want to do that, right? I think what I'll do is I'll say bar positions equals a new dictionary of position and character. And then I'll say for each position? No. For each position? Yeah, I think I just wanted to structure the existing and say position value, and then we can say in positions. And we also need the var row width, which I think I've already calculated this once before, haven't I? Yeah, see these two right here. So let's actually turn these into properties. We can have some properties here, and we can call them private int just max x, and then private int y. Might as well derive those. So down here, where'd I go? Instead of doing this, we can do this. And this. Then up here, we can actually say max x times 2, right? Times 2. Right? So this width was, let's see, the max width was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And oh, that's why I'm doing less than or equal to then. So does that need to be, do I need to add? When you scale it, it needs to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, that's because I'm counting the wrong one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 17, 18, 19, 20. So you need to be 20. But my max x is actually only going to be 9. So 2 times 9 is 18. So I need to add 2 to actually get the actual scaled up, don't I? So I need to say, where am I? This plus 2. Otherwise, I'll be short. And then I need to say bar scaled x equals the current position x times 2. Bar scale factor is 2. This is actually going to be 1 times the scale factor. And then, which is always the scale factor. So that's not necessary. Then we can use the scale factor here too, keep it consistent. So that's the scaled x, and then bar scaled y is just position y. because we're not actually applying anything there. And now we just need to switch. Now we need basically just need to switch over what the value is at these positions, and then put the position in the dictionary with its corresponding value. So we say switch on value, which is a character, and then we'll say case wall. We want to do something. We'll just break for now. We'll say case case wall, case. What are the other cases? Case robot, case empty, yeah, case box, break, case empty, break, case box empty, and then robot. It's got to be one of those, and we break. So then we're going to use those positions in here. So we need to say wide warehouse warehouse map, private read only of dictionary position and actually I think I made this public. There's probably some inheritance we could do here too, but we can refactor to that once we get our answer working. This will have a private, basically very much this, but this is going to be wide warehouse, and instead of that we're going to have this wide, and this will just be new positions like that. Probably overusing this static private constructor method pattern, but I'm honestly okay with it. So wide warehouse map dot from, and then we just need to figure out what we need to do in here. So if it's a wall, we're going to say positions. And let's actually rename this. Let's actually call this F2 scaled positions. And we'll say scaled positions, new, scaled positions, new, and then we'll say scaled X at Y equals wall. Actually, should this live in the from method of this? Because that's not really the wall character I want to use. I don't want to use I guess I could just make it public and say public const character start wall or left box equals right box. And I guess I do want to still use the same wall character, so this is fine. So I can say new scaled X and Y. Nope. Scaled Y. Is wall. And then I also need to add scaled position new scaled X plus 1 Y equals wall. And the reason I need to do that, scaled Y. So the reason I need to do that is because these walls are going to appear here at the ends, right? So I want that, but then I also want one here immediately following it. The box is the interesting one because that's going to be scaled position new, basically going to be this, but instead of those, it's going to be wide warehouse map dot left box wide map dot right side. Yeah, I probably should say left box side and right box side. And again, that's because whenever I encounter a box, I want to replace that box with a left side, and then immediately next to it, I want to insert a right side. And then for an empty, it's going to be same thing. We're going to copy that position, and we're going to say, but we're just going to duplicate it, and we're going to say empty and empty. And then for the robot, all we have to do is just stick the robot where it already was. Right? If the robot's here, oh, it needs to become this. So we'll say scaled position, and then this. Let's see what's it saying here. We can merge these. No, we can't, because this needs to be set to robot. That's my mistake. Okay. And then maybe we have a default case that throws an exception. Throw new application exception. Unknown value present. We could probably say value that should never happen, but if it ever does, we'll know where we are. We won't get any kind of strange behavior if we introduce a value. Row width. Why did I calculate this? I calculated this for some reason. I don't know why it did it. I don't know why I did that. I don't actually think I need that, do I? Well, actually, hold on. Position X, like if this is position X, then that's 0 times 2, which is 0. Which is, yeah, I think I don't need this. So what we should do now is we should test this. So let's go over to our warehouse map. And let's get a new set of tests going on here. Test public async task scale horizontally. When called, it should return expected. Async, yeah, that's to be expected. We'll have a record, and we'll say scale horizontally test case. This should what? We're gonna have a string input that is map input, and then we're gonna have a string input which is expected map. Then we're gonna have a public static I enumerable of func that returns a scale horizontally test case. It's going to be called scale horizontally test cases. This needs to be public. Oops. This needs to yield return our first case, which is just going to be two collections. The first collection is going to be this guy. And the second guy is going to be this enlarged map down here. Then what we're going to do here is we're going to say var expected equals wide map dot from, and we want to give it a test case dot expected. Oops. expected, which is, I think, the first place where we actually want to start introducing some of this inheritance. But for now, we'll duplicate this code and we'll add another from. This is going to be a wide. Then we can say method data source is name of scale horizontally test cases. Scale horizontally test case. Then we can say var result equals warehouse map from the test case dot map input. Then call scale horizontally. Then we can say await cert dot that result dot positions dot is equivalent to expected dot positions. And we should be able to build and see if we implemented the scaling correctly. Where'd my test go? I got to move down here. So close those. Let's run this guy. Oh, yeah, man, that's awesome. Okay, cool. And let me debug that just to visually. Well, I guess for now I can take it for granted because this is just taking the literal input, and so it should be right. Should be right. Famous last words. Should be right. Okay. So the next part of this is we basically need to re-implement this logic. Yeah, I mean, we need to re-implement much of this. Primarily this move robot method is the primary thing we need to re-implement. Because we're not just looking for a box anymore. I guess let's actually use some inheritance, right? So let's say abstract class is a map. And the map is going to have a public read-only dictionary position char positions. It's going to have a private constructor which takes this. It can also share the these froms. This is fine. which should allow us to get rid of that. Because now I can say map. Oh, this should be not. This shouldn't be. Excuse me. This shouldn't be private. This should be protected. Want to convert it to primary constructor? I guess I can. It's okay. So then all we have to do here is just say base positions. That. We don't need this because we have that in the base class. We can also move these to the base class. This should just be map. Oh. Well. I want to reuse this logic. So. Maybe we don't move the from method, the static methods. We leave those on the instance. We leave those there. Maybe instead what we do is we have a static says convert to dictionary like that. Remove this. Which then would allow us to say get rid of this guy. Get rid of this guy. Or we have to leave the body, don't we? But we can say base positions, that guy. This is going to be protected. Convert the primary constructor. Then down here we can say from input say something like this. Say convert to this should be public. Or again, I think this should be protected. And this can be convert to dictionary, and it takes the input. Now we can reuse that. It also means we should be able to then extend this guy and remove this, carry this, the base positions, and from, can again reuse that common method that says new convert to dictionary input like that. Let's see. Scale horizontally is fine to leave here. Let's see, toString, we can also override that in the same place. Override that here. Oops, nope, not there. Override that here. We can also lift up these properties. Here, instead of private, they're going to be protected. Protected. Let's see. This should also get lifted up to this class. And it can be protected. Oh, that can be made private because we're only using it in the toString method. Now we've cleaned this up a lot. We can lift these to the abstract class as well. Although these need to be protected. That. Be protected. Now, these should also be lifted up. Now these can be protected as well. We don't need to call them outside the inheritance structure. Okay, so that cleans up our methods a little bit. So that's our constructor. Those are our two static methods. This is us scaling one horizontally. But we still have to re-implement these because these are different. Yeah. And I think the one we want to focus on, I'm going to add another test for our scale horizontally method, just for my own sanity. Yield, turn, this is going to be new. Actually, just let me copy this. And this guy is going to be our starting point. I will say advent of code does really take it does take time, it does take effort, especially if you're like me and aren't like a whiz at this kind of programming, and in general are just not very fast. It's a serious time commitment. So we are scaling properly. This is the test though. This is the part that's difficult, is the box moving. So when you push horizontally, that's not so much an issue, right? Because we can just, for moving left, we can just check, is it a box thing? 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 Until we get to the, until we basically still get to an empty. This, though, when we're pushing vertically, so when we're pushing vertically, we have to basically say, now we have to do something a little different. We have to, we basically have to go to the widest point, right, and make sure that that's a box. Then we need to check, is the next thing a box? And if the next thing's a box, we need to go wider still. So it's almost like, oh, okay, this is the start of a box. Then we need to also go to this one. Then we need to check this guy. And we also need to check this guy. So what does that mean? That means we're always checking back, back, and to the left. Then we're back and to the left, right? If that's a box, then again we're back and to the left. Well, shit. This is tough. Okay, so I don't see a good way to reuse the code we've written so far. So we're gonna have to re-implement this. See, we're gonna re-implement this method. We're gonna re-implement this method. We'll have to re-implement the calculate total box GPS coordinates and the move robot. We're gonna have to re-implement all this. So we're gonna copy that over to our wide warehouse map. And what doesn't it like? Oh, this is going to be a wide warehouse map. Okay, so the first thing we can do is our calculate total box GPS coordinates. That needs to change where, So the box shown below has a distance of 1 from the top and 5 from the left. 0, 1, 2, 3, 4, 5. So this is where we basically just need to say KPV value is box, this left box side, which is pretty straightforward. And we can actually make that an abstract method on our map class, and we can say we can say abstract int calculate whatever this is called. Oh, there we go. What's it not? I want to say public override. Well, yeah, because I have to implement it, right? So if I don't implement it, then I have to implement it. Yeah, okay. Then down here, say public override. Is good. And then let's see. I need to move my robot. So a lot of this is the same. If it has an next position, it's false. If it's a wall, we continue. If it's empty, we move the robot. But it's here where we need to where we need to do something different. And I think we even need to probably take in the fact that direction. So I think it's going to be either we need case box left box side and can push box and then right box side can push box. Then we need to do stuff differently in the can push box. So if let's go back up here. Okay, so if next position equals box position dot get next position in that direction. Yeah, so it has the next position. I think this is going to be this. All we need to do here is we just need to say left box side or case or case right box side. Then we continue. When we hit an empty, then we return true. Otherwise, we return false. Then when we push the box, so maybe we can reuse those methods. Let's see though. Because it's when we're pushing vertically that I think things get weird, right? Because pushing vertically, it's just going to keep walking backwards, which isn't enough, right? Because you can see like here, this would say, sure, you can push it back, but really we can't because this is here. Is this where we could use a Q? Can we use a Q here to solve this? So I guess what I'm thinking, is that we could say var Q new, or maybe box positions equals new Q of position, and then box positions dot on Q the box position, and then we say while box position dot docs position dot count is not 0. What are we going to do? We are going to say well, we need to know the direction we're going. So, or we need to know which of the boxes we found. So, I think what we're going to say is we're going to say our current position equals Q equals box positions dot BQ. Then we have our next position. So if positions current position if that is a left box side, we're going to do something if positions current position is right box side, we're going to do something different. So if it's a right box side, we need to get the position to the left. So let's do that. If this is going to throw. Maybe we do or has current position equals positions. I'll try get value, and we'll say bar position value. Then we can say this. We can say if has current position, just continue. If has current position is false. Which I don't think we should ever hit that, but defensive driving. So if it's a right box, right, we're going to say var get other, or var box left position equals box left is going to be equal to current position dot get next position direction dot left. Oh, I think I made those private now. At least left and right. Where were we? We are determining if we can push it. So that's the left box, left box side position. And what do we want to do there? We basically want to then we want to say var next position equals current position dot get next position, and in that case we just want to go in the direction we're already going. So that means we're going to look left and we're going to look down. And what are we trying to get to? So I think what I want to do is I think I want to box positions dot enqueue left box position dot enqueue well, I guess we can already get the next position, can't we? Var next position equals current position dot get next position direction. So what would happen if this was empty? If the next position was empty, I guess I just want to walk my way back until I get to empty. And so if current position is if next position is empty, we just continue. And maybe we return false here. Var as next position. Same thing here. Or next position value false. Turn false. Oh, as next position. And then if next position value so if next position is empty, I don't want to queue anything, I just want to continue. Or if next position value is a wall, if either of those things are walls. Otherwise, right, next position is empty, we just continue. If current position value is the right side of the box, then we are going to enqueue the left box to be looked for. And if we've gotten here, then we know we also need to if the next position is not empty and it's not a wall, then yeah, if it's not a wall, then it's got to be a box of some sort. So then we can say box positions dot on queue next position, I think. Yeah, I can just, let me delete those for now. Then I think this is going to be var right box side position. Q right. In which case now I don't need any of this. And then I can just return true. So my thinking here is that, just kind of thinking about this, right? I detect that there's a box here. So now I call can I push the box? That takes the current position, so we'll get the current box position. We'll also get the next position. And we'll say if it has a current and has a next, then we'll come down here and we'll say as long as the current position isn't a wall, which it shouldn't be, because if the current position is a wall, we're in trouble. I think it's if next position is a wall, return false. If next position value is empty, continue. Then what we'll say is switch current position. If it's the right side, we'll get the left side. We'll enqueue the left side. So let's say this is empty, just to for instance. If this is empty, then, and let's say this is empty as well, it would go here, empty. Oh no, we don't want to continue here. We don't want to continue there. I think we need to keep checking. I think actually what we need to do is we need to say if next position is empty, continue. Yeah, so we'll go here, we'll enqueue the left side. If this was empty, then we continue, and then we just look at the left side and we say, okay, now I'm on the left. Oh, we also need to track keep track of visited, don't we? Because I don't want the left trying to do that side. I don't want to get stuck going back and forth, back and forth, back and forth. We'll be right back. Kid stuff. 1 sec. Okay. What was I thinking before I got distracted here? I'm thinking that I'm basically trying to get to an empty queue here is what my theory is basically I'm trying to get to a point where there's no more box positions to look at. Because we've looked at them all. So if has current or has next is false, or if the next position value is a wall, then we have a problem. Otherwise, the current position is a box. That's why, because we're in this method, we can assume that. So we need to get the position for the other side of it. But only if, right, because right is going to then NQ left. And then left is going to try to NQ right. So we need to have bar visited positions equals new hash set of position, and we need to say if current position basically just need to say if visited positions dot contains current position. We need to continue. Otherwise, visited positions dot add. Which should protect us from going back and forth, back and forth. So we'll visit here. Then we'll visit here. So yeah. There's not really a way, because this is a private method, there's not really a great way for me to test this, but I think it's doing what I want to do. So left box side can push the box, right box side can push the box. And then if we just step through this, if it's a right-sided box, we're going to get the current position, we're going to add it to using visited positions, we're going to get the next position in that direction. Yeah, we're gonna get the next position, which is down, which is gonna get enqueued. Then we're also going to queue the left side of the box. Right, and we go left, we go down, we go down, we go right, we go left, we also go down, this one's going to go down, this one's going to go down, they're all going to go down. So I think that, yeah, I think that's going to do what we want to do. Now we need to actually push the box. So I can push it. Now how do I push it? So in this scenario, I basically need to do a very similar thing. Need to do a similar thing. Which feels like I'm doing double the work, honestly. So maybe I shouldn't be doing this. I think that needs to now be position. So how did I do this in the other method? Can push box. Push box. Oh, I just created a new copy locally. So this will be our positions equals new, or equals current positions at 2 dictionary. And we're going to do similar work, only now what we're doing is if it has a current position as false or has next position as false, we want to just return the positions. If the next position is a wall, we return the position. Otherwise, if it's a right-sided box, well, actually, I think otherwise we don't really care, do we? I mean, we still need to. I guess here is where we want to do our replacement, right? So if next position is empty, if the next position value is empty, so if we get to here, and this is empty, then we just want to swap these two. So the current and the next, we want to swap them. Yeah, even here, that would ring true, right? So this could swap with this. This could swap with this. So what did I say? I said positions. The next position equals current equals current position value, and then positions current position current position equals next position value. So that basically means at this stage, this one becomes this one. At this one becomes this current. This is my current. This is my next. My current goes to my next, and my next goes to my current. Right? Yeah. Which I kind of feel like means that I don't really need this. Or could I just bail early? Like if I encounter any of these cases, could I just return the unmodified positions? Thinking I can. But let's try it the way we have it right now. So what we want to do is we want to add a new test class called wide warehouse map tests. And the one that I'm interested in is I'm actually interested in the move. So let's copy all these guys. This is the tricky bit. Oh, we also need this. And then we're just going to take away all these cases, or at least comment them out for now, except for the first. Comment those out. And instead of a warehouse map, we're going to say wide warehouse map. Wide warehouse map like that. And then we're going to start working through these. So here's our initial state. State. Then we're moving left, and then it should return this, which is the same thing. right? No, we should move the boxes. So moment of truth. This one could be kind of tricky to figure out. Okay. Let's try to understand what the heck we're doing. We'll put a breakpoint there. And we're going to go in here. And we're going to try to understand what we're doing. Why didn't that hit? Move robot. Let's debug it. So do I ever get in here? Yeah, okay, so I do. So 9-3, and I'm going left. Let's step over this. Current position should be 9-3. It should skip over that guy. It's gonna add it. Now next position is 8-3, and that's gonna be a box. So we should step over that. We should step over that. It is not. It is a right. So it should say box on cue left. Then it should say if next position is empty, which is not. We on cue. We basically on queued it twice. Okay. Then we step over and we dequeue it. We visit the add positions. Next position is going to be another right. Oh, no, it's a left. Yeah, current position left. So left is going to try to on cue right. Which next position is 7-3, which is this guy. 0, 1, 2. 6, 7. Now we should hit some of these contains. Continue. Contains, continue. Okay. Let's see. This shouldn't be a unique one. His current position wall. Oh, I guess. What? How do we get all the way to a wall? Oh, next position value. So that's here. Left on cube, break. Q. Okay, next position value is an empty. So if next position is we continue, count is 2, but I think these all should be unique. These all should be places we've already visited. So now count is 0. So now we return true. Step over. Boxes. What position? Okay. Guess what I'm looking for is this should now the robot 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Would be 9. Three. And then 8, 3. Yeah, so our push, there's something wrong with our push box because this should be, it should be a right box, left box, right box, left box. And right now it's messed up. So let's try to understand that, shall we? So we're close. I think our can push box is right, at least for the horizontal, which I think will make it right for the vertical too. Let's see. Not can push box. We should be pushing the box now. We should never run into this. What I'm wondering here, though, is if we're running into some sort of let's just try to step through this. Debug unit test. Okay. All right, now current box position's 9-3, so we should DQ that. On a wall. I'm wondering, should I be moving this right away? I don't think so. So that's going to screw up the next. Like, should I be moving this here? And moving this to empty? No, because then I lose it. It's got to be in reverse direction. I've got to move this one here, then this one here, and so on and so forth. So let's get to the point where this is empty. So when this is empty, what does this look like? This just has 8 and 9-3. So and let's see, next position is 7-3, 8-3. Position. Okay, so now I'm here. What's in my queue? Oh, it does this. It does the replacement. But now the current position is going to be DQ'd. And it's now going to say current position is X3, but X3 is in your So what happens if I don't worry about this? Bug. Nine three. Yep. 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 Okay, so we're empty now. And what does my queue look like? Box positions is 10. So we're going to say next position. Yep, and then this should get put to the period. We hit this again. Current position. Yeah, so this is just now just kind of growing uncontrollably, getting larger and larger and larger, and just sort of repeating itself. So what happens if I do position value is empty? So we have 4 there. That's not working. Is it not working? Well, why is it not working? Should I be using a different data structure? Should I be using a stack instead of a queue? Right, a stack is first in, first out. No, a queue is first in, first out. A stack is a stack. Stack versus queue. Yeah, so a queue is first in, first out. A stack is last in, first out. So what do I end up when I've exited this loop? Leaving everything else the same. Oh, hold on. So visited positions at this point is 6, 3. Which is what, 6? That is the 0, 1, 2, 3, 4, 5, 6, 6, 7, 8, and 9. Which at this point, that, I mean, if I've reached all the way down here, that means I can move them because I found an empty. Which means I just need to shift these 1 in the direction. For each position, shift it 1. Right? So I would say for each bar position in visited positions, well, no, I need to start from particular end. I do get here. I think I want to reverse the thing. And then let's see, I say for I don't want to do it this way. I don't want to do it this way because once we start moving vertically, it's not that simple, right? Because right now it is simple because we're linear. But the minute we start moving vertically, it's not as simple as just well, I guess actually it is, isn't it? For each position, get its next position, and then swap them. Get its next position, swap them. Get its next position, swap it. for each position in visited positions dot reverse. This guy is going to be here. This guy is going to go here. This guy is going to go here. Let's just try it. So for, we'll say var current value equals position, var next value equals positions, get next position, and then we swap them and we say position then you say position next position equals current value and position next value. I'm also going to add a class. I'm also going to add a property to this map class. That is just private string map, and this just calls that toString method. Oh, map grid. Copy. Debug. Oh, don't debug all. I don't want to debug all. Oops. I don't think it. I don't think it moved anything. Okay. Oh, it's not. Oh no, it did. It did what it was supposed to do. Sorry, I was looking at the wrong thing. So the result grid look exactly like the expected grid. So I'm not trying to see if this moved compared to this. These should just be equal, and they are. Okay. Let's add some more tests. Right? Sound good? So let's see. We did the first move. Now let's try this move. Uncomment these guys. So now this is going to be our new state, our new starting state. And then let's see, this is going to be to the downward direction. Downward direction. So the hope is that this becomes this. That. Again, we'll build. Now we should have two cases here. Let's work. The real telltale is going to be the vertical movement. Okay, so now this guy becomes our new starting point. Put that guy here. And then we're going to move down again. So now this becomes dot and at. Build. This is the only, I mean, this is painful to watch and painful to kind of do this, but this is the only way I know how to know I've got it right. Like I mean, I could sit here and just run and print things to the console and everything, but doing it in a very methodical way like this at least lets me know I'm moving in the right direction. And while painful, definitely, I think it's more productive than throwing things against the wall and seeing what sticks. Let's see. So now we're moving left. So we want the at sign to be here and this to be period. Yeah, we're doing good so far. But we haven't got to the trickiest case, which is when we get to moving vertically. This one's gonna be here. Oh, whoops. I don't need to do that. That's a waste of time. So this can go here. And now we're moving left. We expect our at symbol to be underneath. We rerun. We should have 5 passing. Great. But this is where things get tricky. This is where we'll find out if my logic is busted or not. So that is now our new start state. And now we are moving up. And now after we move up, this whole thing shifts. This whole thing shifts. And this is the piece that I don't know if I captured correctly in my logic. We are about to find out. Oh, joke. Did that really just work? Yo, I'm pretty proud of that. Yeah, I'm pretty proud of that. So this is my starting point, and this is also my end point. And we're just moving up again, so nothing changes. But now we're moving, so that should work. Cool. Yep. So this is going to be my starting point. And then we're moving left now. So this is going to be my end point, which is essentially just this thing again, with my robot shifted over one. This should be my starting. Oh, I need to uncomment this. Starting point. Moving left again. So now we're here. Oops. Here. Then again, we're moving. We're just going up one. We should be right next to the boxes now. That. Oh, and we should be moving up. So then that becomes our starting point. This time we're moving up one more time, which is another tricky vertical movement. Didn't mean to do that. In which case, this becomes. Was there less movements here? I guess there's less movements here. In which case, these two get shifted here. This becomes at dot. Dot. And let's just make sure I have the right number. 1, 2, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11 moves. Okay. Nice. Okay, so then we just need to calculate our score, right? Let's see. Map input, directions input, expected value. I think I can actually just give it this, huh? So let's change this to say map input, expected value. Well, guess we should actually test the move. Just make sure we're calculating this right. So this is just a collection, strings. So it's going to be 9021. These get shifted over. Multi-cursor, fuck the world. Every text editor should have multi-cursor support. Oh, I'm missing a parens right there. And we don't really need the directions. And we don't really need to move because we are just giving it the final map. That means that we can just verify that when we get to the final place, we actually are calculating that total correctly. Found 0. Well, that's not good. We're calculating the 0. Oh, I know why. That's why. Because we want wide warehouse map. Nice. Okay. So are we confident enough to try to use this to solve the actual puzzle? Well, let's give it a go. This was just for debug purposes. We actually don't need that. Yeah. So how do I want to do this? We're going to say parsed map. And then we're going to say var map equals is part 2. And then we're going to say, if it is part 2, parsed map dot scale horizontally. Otherwise, it's just the parsed map. Oh. So scale horizontally should actually return scale. Let's see, scale. We want this to return just the map, that common interface. And we can say, what else can we say? We can say the puzzle parser also just returns a map. I mean, that's the whole benefit of being able to have that abstract class. I mean, obviously we get code reuse too. So this is just gonna. So this method needs to become abstract. So we say public abstract, and it should just now return a map. And then in our derived classes, we need to say override map. Same thing up here. Let's see. Public override runs a map. Then the last piece of well, in this case we're returning a warehouse map, and then in the case up here, returning a wide warehouse map. Then we also need a scale horizontally. Where's my scale horizontally? Here we go. So I think we'll make this a virtual method. I think what we'll do is we'll say map scale horizontally. I think we'll make this virtual. In which case I think we'll just return this. So by default, it's not going to do anything. But if we override it down here, then it does something, which means now, which now we don't even have to check. We don't even have to check for part 2, honestly. We can just say map, and then we can say scale horizontally, move the robots, and calculate the total GPS. Well, shit. No, that doesn't make sense. Because this is just going to return nothing. So hold on. Go back. I think we just do that. I'm actually going to rename this too, and I'm just going to call it scale. Because technically, the overriding member can do whatever they want. They can scale it however they want to scale it. Yeah. I feel good about this. Let's try it. This would be pretty awesome if it worked. Yes! Let's go. Let's go. So that was my goal for this year of Advent of Code, was to get both stars on day 15. So regardless of how the rest of this year's Advent of Code goes, it's a win. A win is a win. So let's real quick, let's write a couple tests. So we did part 1. So let's add the part 2 here. Part 2 solution. We are going to parse the map. We are going to scale it. We're going to move the robot, and then our total should be this. Yep, be that. Run our tests. Oh, we need to change the name of these. I wish when I click this, it would go to the file, the test file. Let's see. Warehouse map tests. This actually should be renamed to just a scale. This needs to be just scale. Scale here. Tests. Run them all. They all passed. Great. Okay, so one thing I want to try to remove is I don't think this is necessary here. Yeah, I don't think this is necessary here. So I'm going to try removing these conditional checks here. Rerun. No. Which one is this? This wide warehouse test. Debug. Which one are we moving here? We are moving up. Let's see, expected. This is why I need that. I just need to leave it. Public. Make it public. String equals map grid, which is equal to toString dot split that, and expected. And what did we give them back? So yeah, so could I then do current position? Let's see. C# dictionary quality. really just only this method will test that it contain the same keys with the same values. Dictionaries. Dictionaries equal by reference. Yeah, dictionary is a reference type. So what that means is that if I just return back the current position, then up here I can say are new positions, and I can say if new positions is position is equal. What do we want to do? We just want to break out of there. Otherwise, positions should equal new. Yeah. Which means I can get rid of this. And the reason I was trying to do that is because I'm doing the same work twice when I could just do it once. So remove that. And then I'm curious if I'm curious if I can reuse. So let's see. Let's just try it. This is my move robot solution currently. Let's replace my first move robot solution with the one I implemented here. And the only difference is I will return a warehouse map. And I will also add a new case for case box like that. Let's see that. Something broke. Why did part 2 break? Oh, that's weird. Right? That's weird, right? I wouldn't think this would impact. Yeah, I was expecting that, so it broke part 1. Well, I'll leave them separate then. I feel like there's a way to probably reuse it, but this is fine for now. Okay, let's start pulling this stuff into its separate classes real quick. So this guy is going to go into its own separate class. Namespace is going to be warehouse woes. You need to start using this guy is going to go into its separate class. All in the same namespace. This one goes into a separate class. Space. Good handy direction class. And that just leaves us with our position. Where'd it go? What's gonna happen? Wonderful, wonderful. What was my speed on this? Pretty fast, right? I'm happy with that. Okay, we need to do the README. Problem. D, problem in D. This is gonna be slow. This breaks my previous star. With a pretty Okay, let's commit this stuff, huh? Solve day 15, part 1 and part 2. Or no, this was part 2 only, huh? Okay, now comes the real question, right? The real question is, do I start on day 16? They don't know. I probably should. If I at least did one part tonight, that would move me closer to where I need to go. Yeah. Okay, here's what I'm going to do. I'm going to say that was it. Advent of Code day 15. We're going to stop there. And then I'm going to continue on to Advent of Code day 16.